am Anil Kumar. In this video, we will discuss another important test question which is based on implicit differentiation. Complete solution will be provided. We need to find the equation of a tangent line and then sum of intercepts. You can learn from me by joining my classes. Send an email on the address given. Let us now enjoy the journey of success. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss with you a test question which is based on implicit differentiation. The equation here is, given the curve C defined by square root of x plus square root of y equals to square root of k, and the line L tangent to the curve C, prove that the sum of intercepts of the line L is k. So that's the question for you. You can pause the video, answer the question, and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given. Now let's see, how do we solve such a question? We are given the relation which is square root of x plus square root of y equals to square root of k. A line L which is tangent to the curve, and we need to find the intercepts of this line L. So first step is find equation of line, correct? So to find equation of line, what can we do? So equation of line L. We can write this as y equals to mx plus c, where c is the y-intercept, but we need to find the gradient m, the slope m. So for that, we can differentiate implicitly the equation with respect to x. So let's do that. So we'll do d dx of square root of x plus d dx of square root of y should be equal to the derivative of square root of k. Derivative of square root of x, as you know, is 1 over 2 square root x. That of y will be 1 over 2 square root y dy dx. The chain rule, perfect. And for a constant, the derivative is 0. So using implicit differentiation, we easily found the derivative, and now we can isolate dy dx. So we can say 1 over 2 square root y dy dx is equal to minus of 1 over 2 square root of x, or dy dx equals to minus 2 square root y over 2 square root x, and that simplifies to square root of y over x. So we get derivative of the tangent line at any point on this curve. Now, let us say that the point which we are talking about is AB, right? So let's say let AB be the coordinate points, right? In that case, what happens? We find the derivative of this particular function at x equals to a and y equals to b, and that gives us minus square root of b over a, correct? So that becomes the derivative. That is the slope, right? Now, we know the coordinate point, we can find the equation of line. So equation of line will be what? Y equals to the gradient minus square root b over a times x plus c, right? Since we now know that m is equal to minus square root b over a, at a point P, which is AB for us. Since point P is AB for us, we can find the y-intercept by substituting A and B for x and y, right? So we're looking for a point P, which is AB for us. Correct. So let's substitute and continue. So we have B equals to minus square root of B by A, the x value being A, plus C. Taking this to the right side, we get what? We get B plus square root of B, and that simplifies to A, right? E equals to C. So this gives us the equation. So the y-intercept is clear to us, right? So y-intercept is B plus square root AB, you can say. So that gives you the equation of tangent line. At a point P, which is AB, right? And the equation L for the line is y equals to minus square root of B over A times x plus B plus square root of, you can write AB, correct? Since that is your y-intercept. Now the question is, we need to find x and y-intercepts of this line and prove that the sum of intercepts is k. Perfect. So let's move on to the next page. We'll write down the equation. So the equation for us is, we know the y-intercept is b plus square root ab. So we know y-intercept is b plus square root ab. And therefore the line equation is y equals to minus b by a x plus b plus square root ab, correct? Now let us find the x-intercept. X-intercept means y equals to 0. So if I substitute y equals to 0, I get what? I get minus square root b over a. We need to find the x-intercept. So let's rearrange. We'll take minus b over a on the left side. It becomes plus. And we have b plus square root a plus b. Isolating, we get x equals to a over b square root times b plus square root ab, correct? Let's open the bracket. So we get what? Square root a over b times b plus square root a over b times square root ab. And that gives you square root of ab plus, here we get square root b cancel. We get just a here. So the y-intercept is b plus ab and the x-intercept is a plus square root ab. Now, what is their addition? What is their sum, right? Let's figure this out. So we can say that the sum is sum of x and y-intercept. Is basically square root of ab plus a plus, we have b plus square root ab, right? Which is a plus 2 square root ab plus b, right? So that is what it is. You could write this as square root of a plus square root of b whole square, right? So this could be written as square root of a plus square root of b whole square. And you can see, if the point A and B is on this curve, in that case, we know what? Square root of a plus square root of b should be equal to square root of k, correct? And therefore, this should be equal to square root of k, correct? So whole square, when we square it, we get square root of k whole square, which is equal to k. Perfect. Because square root of a plus square root of b is square root k. Now if you square that, you get k. So hence proved. Do you see how we have proven this identity. Now, it's a very interesting example, and what we've just done here is shown you all the steps required to prove this particular identity. I hope you understand and appreciate it. Now, related with this, we have another question. But just in case you want to learn from me, you can always send an email on the address given. Here is your practice test question. You can always do this question, right? So this is your practice test question. We have square root of x over y plus square root of y over x equals to 10. Of course, denominator cannot be 0. Therefore, x and y cannot be 0. You need to show that the derivative dy dx for the above relation is y over x. Okay? So I hope you find it interesting and useful. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.